introduction. That was rather more than I needed because I don't expect to be speaking for very long out here. I'm just here to introduce Bob Steneck, and in introducing him, I know that I don't have to tell anybody in this room that our Earth is in dire trouble. The news of climate change has really dominated headlines almost to take Trump out, not quite, but coming close. And I hope we'll continue to pay attention to that as we lurch through the next crisis in Washington, because the oceans are warming, and the chemical structure of the oceans is changing, and both of these are happening at almost frightening speeds. The Gulf of Maine, our great body of water out there, so full of fish once upon a time, is one of the fastest forming bodies of water in the world. And we've seen directly what that does to our fish populations, from lobsters to clams to haddock and cod to the black sea bass that are now moving in. Aquaculture can help with this problem, at least help with the business of getting fish from the water onto our plates. But aquaculture comes with its own set of problems. So when I puzzle over this rather ominous predicament that we find ourselves in, I can't think of anyone who can make more sense of it than our keynote speaker today, Professor Robert Steneck of the University of Maine School of Marine Sciences. That's the Darling Marine Center. I always have to stop when I say that. That cute little marine center, that Darling Marine Center, down in Walpole on the banks of the Penobscot River. From coral reefs in the Caribbean to kelp forests in the Gulf of Maine, Bob Steneck is the man you go to when you're trying to figure it out. And what is it? It is the way we're all connected in this vast, vast network, from the microplankton at the bottom of the food chain to the whales at the top, and to all of us humans who are in between, who depend so vitally on the sea and all that's in it. So for the big picture, I can't think of anyone better at telling it like it is than Bob Steneck.
Well, it's great to be here. Actually, my age is not great to be anywhere, but Mark once said that if I had more time, I would have given it a shorter piece. I have to say the same about my talk, but as you can see, I was charged with talking about the current state of the Gulf of Maine, but this is really a story about change. And you know, some change is really obvious to everybody. But you know, lots of people have the sense that the sea doesn't change. And you know, if you look at the surface, you might be fooled into thinking that. But some of the changes are profound, and they create a new normal. It's really quite different from the past. And I think that it's from that perspective that I want us to be thinking about what it is that we have on the coast of Maine. You know, if you were to be diving, you might see something like this: lobsters, crabs, feeding on some bivalves, some mussels, and kelp. And this is kind of the system that I saw when I first came to Maine. I started working in the mid-1970s on the coast of Maine. And what I didn't ask is this a human-altered ecosystem? And I'm going to get back to this Maine coastal story, but really it's a bit about the bigger picture first. In a paper that was published in Science, and this is a very highly cited paper by Jeremy Jackson, sitting right over there, about historical overfishing and the recent collapse of coastal ecosystems. And I'm going to argue that Maine is really a microcosm for this global story. And some of the evidence is as old as our species arriving here on the coast of Maine. And human impacts affect much of what we see in the ocean. One of the figures in that is this figure. This is known in the field as the Jackson 5. You've probably heard of that before. But human expansion, beginning with overfishing, moving through pollution, mechanical destruction, introduced species, climate change, these all contribute to altered ecosystems. And one of the points that I want to make today is that actually all of those points actually work in both directions. And now we're looking at climate change as it's feeding back into introduced species, into fishing. But first, let's set the stage for the Gulf of Maine. You know, we're in the North Atlantic, okay? And so you are here. And, you know, I'm going to focus heavily on the western North Atlantic coastal ecosystems. But first, I want to start off with their assembly and disassembly. It's important for setting the stage. So if we think about the North Pacific and North Atlantic, the poles began to cool about 15 million years ago, and the Bering Straits opened about 5 million years ago. So the relatively diverse Pacific biota actually made its way into the North Atlantic. The North Atlantic is a young ocean. It was warm for most of its history, and when it got cool, it got its players from the North Pacific. So it inoculated the North Atlantic. But in a paper that we did a couple of years ago, we looked at some of the key players in the North Pacific ecosystem, and starting with the mid-Miocene cooling, and then going to the opening of the Bering Straits. You look at kelp, pinnipeds, our seals, sea urchins, cod, and what you find is, in terms of the taxa that arrived in the North Atlantic, it's only a subset. About 25% of these important players in the North Pacific made it into the North Atlantic. Now, there's a reason why I'm telling you that this is a relatively young cold water ocean. It was incompletely inoculated in the North Pacific. Then there are those pesky glaciers that come in every 120,000 years. We had 2 miles of ice over our head 18,000 years ago. That adds to the extinctions, and it leaves us with remarkably low species diversity. And you know, so how low is it? Well, a study done by John Whitman and some folks at Brown University went on a kind of a dream project, going all these places and dropping quadrats and looking at how many species they found. And as they dropped their quadrats, you can kind of see what the numbers work out to be. And so, not surprisingly, the tropical Indo-Pacific had the highest diversity, and tropical places like the Caribbean, kind of middle of the road. But here's where the Gulf of Maine comes in. Absolutely dead last. And so, when you think about just fish species, for example, there's a very clear pattern. This is Ken Frank's work. Very clear pattern of lower diversity at higher latitudes. But what you see in the Gulf of Maine is something on the order of 100 species of fish in the Gulf of Maine. That's a really low number. If you go to Kimby Bay, Papua New Guinea, there's 1,600 fish in that bay. So we have a low diversity ecosystem, but it's highly productive. You know, the kind of thing transferring solar energy, nutrients, highly productive. But a very simplified food web, which I'll talk a lot more about. And it creates very strong ecological interactions. And those strong interactions create these booms and busts that we have in the populations here, which are almost unprecedented globally. Now, there's a number of ways of illustrating that, and I will illustrate it over time, but we end up with some very big predators. The cod that made it into the North Atlantic, it evolved into the largest cod on the planet. We also have one of the largest mobile invertebrates, and one can say that we're in a boom for them and a bust for the others. I show you these pictures for 2 reasons. One is we do know that cod, major predator, was really big. That's a picture taken of Monteague in the 1800s. And then I also wanted to impress you with how big lobsters are. You can see its claw relative to my hand. But also, this is, I think, the ugliest picture ever taken of me. So what was natural? If we could really ask the people who were first setting up camp on the coast of Maine, what is it that they were seeing in their ecosystem? Well, to get a handle on that, we do turn to the Penobscot Bay and the Turner Farm, where the best archaeological studies have been done. And in those digs, and Bruce Cork actually did most of that work, so we can ask him specifically about these details. But working with Bruce, he showed me these fish hooks carved out of deer bone that are carbon dated to 5,000 years ago, and cod vertebrae, which are much bigger than any vertebrae in this room, over 4,000 years ago. So we know that cod were a very big player. And when you look at all the bone fragments from 400 years ago to 4,500 years ago, you find cod dominating bone fragments. Flounder next. Sea mink, which is actually an extinct mink, was next. There are sea urchins, which don't preserve terribly well, but they are present. Don't ask me how it is that they got a great white shark, but they did, and they dragged it up to the Turner area, and it ended up being buried. But the real news here is that there are no lobsters or crabs. And they preserve in other places, but they aren't found in these ancient prehistoric middens in Penobscot Bay. Moving to Booth Bay, another Indian midden shows about 85% of the bone mass is are codfish bones. But importantly, part of the study that I did with Jeremy, we sized the cod on the vertebral diameters, and they were about 1 meter in length for thousands of years. So that's the average size. Of course, they're getting bigger ones, and if you're fishing from a canoe, one has to assume that there's a limit to how big they could be. But what we're able to do is go into the bones that were found in the Turner farm, and you can use I do an isotope study of the carbon isotopes and the nitrogen isotopes, and that kind of tells you what they were eating. So if it was nearshore carbon, seagrasses, and kelp, meaning it's a very coastal environment, it will plot in the upper right-hand corner. The plankton would be more in the center. And the plot actually shows as follows. It shows you a couple of things. For one thing, it used to be thought that the early people were feeding mostly on deer and bear, but if they were, the nitrogen and carbon isotope signature would be really different. What it shows is that the cod, sculpin, and flounder are all showing signs that they were very much coastal, part of the seaweed community, not the plankton community. And then the human bones show a very strong association suggesting that, in fact, the first Mainers ate seafood. And they did that for thousands of years. If we fast forward to the 1600s, and this is the Weymouth voyage coming up to Penobscot Bay, what Rozier wrote, he was the first naturalist on the coast of Maine, was he talked about the great cod and haddock, which gave us a taste of great plenty of fish wheresoever we went upon the coast. So what we're really dealing with is a coastal system that has 5,000 years of fishing. And a lot of that was codfish, and as I showed you, a few other things as well. But if we just consider where we are right now, the Penobscot estuary, let's just consider that. If you take this illustration of this system going up to Bangor, and you subdivide it into a couple of different segments, river, estuary, upper bay, mid bay, and lower bay. And then you look at just the fishing, the records of landings. As it happens, towns kept very good records of landings, which really surprised me. You know, I'm more of a biologist than a historian. And it turns out that the very earliest records showed very strong landings way up the river, but then they declined. The estuary, you see this moving down. This is a serial depletion that's going on until you get to the lower bay, which actually shows this very strong abundance of fish that are being landed in that region. But at that point, technology got to the point where there was quite a distant harvest going on Browns Bank, on the Scotian Shelf. And so what we're seeing is the evolution of fishing, which involves the changing targets due to fisheries-induced impacts. And probably the best way to illustrate this is the very first person who mapped fishing grounds on the coast of Maine was a guy named Good. He did the work in the 1830s, and he published this in 1887. And so you can see where Penobscot Bay is. The Turner site is in this image. It would be right there. But here's where I'm going with this, and that is, you see that there are 4 areas that are off of Mount Desert that were described as productive fishing grounds. Notice that the circle around what is now North Haven and Vinyl Haven and Isle of Ho it was not identified as a fishing ground at the time. Now, this is work good. If you go to the, fast forward about a century, a fellow named Rich did the same kind of mapping exercise. And you could say that those purple circles are either the good fishing grounds described by Rich or the rich fishing grounds described by Good. goes either way. But notice that, that the Penobscot Bay area still does not show to be a very important area for fishing. And then Ted Ames did his famous work taking oral history of fishing grounds going back to the 1930s. And what he was able to learn was that the fishing grounds no longer were those good fishing grounds off of Mount Desert, but now the region around Vinyl Haven and Isle of Howe was what's being targeted. And the real big difference here is the technology. It wasn't just simply motorized vessels, it was the capacity to refrigerate spawned cod, which otherwise would rot relatively quickly, and also a lot of the transportation capacity was such that you could get cod to market. And that technological evolution was central. And it looks to have been the point of time after the 1930s when most of the cod and haddock stocks from Penobscot Bay collapsed. So we know that the fishing capacity has significantly increased over time. That's not too surprising. So when you look at all the landings in Penobscot Bay starting in the 1880s, you see a improved fishing gear, improving the landings. And then you'll see a increase in technology that allows purseines, refrigeration, and improved transportation. And now we're starting to see those local landings decline. And then, as we get to the recent, you start seeing this come up again in terms of what's landed in Penobscot Bay. This is herring, redfish, and lobsters. And I think that this is reflecting not just the increased capacity, but also increasing value. What was valuable versus what is valuable now. And a good illustration of that is just looking at marine resources from the 1880s. If you correct for inflation, the value is like $19 million in the 1880s. More like today, it's $323 million. Much more value when you correct for inflation. And then when you look at what was actually literally landed, you see the following interesting patterns. There's a much higher diversity in the 1880s. Mackerel was #1 in terms of value in the 1880s. And that's because of fish oils. Cod was a significant component. Lobsters only made up 24% of the landings. Today, when you look at the situation, 92% is lobsters in Penobscot Bay. And I'm going to get back to this, but this is both good news and bad news. But whereas there was a coastal depletion, nearshore depletion of codfish, the National Marine Fisheries Service trawls of codfish throughout the Gulf of Maine found, you know, if you sum it all up from 1968 to 2003, just happened to be the data I had handy, you'll see a very interesting pattern over the last 30 years. In the 1970s, you actually had a reasonably good collection of codfish all the way around the Gulf of Maine. By the 1980s, it's starting to break up. 1990s, breaking up even more. And after around the 2000s, we're talking about coastal Maine, which is largely devoid of not just cod, but actually most of the large predatory fish. Well, so what? Well, the somewhat on this is that I was doing some research with lobsters. I would tether them. I had an ultra-low light camera that would be watching lobster predation. And these lobsters can't hide. They're sitting out there. And I would have this going day and night. I did this for 4 years. That's a little, Connor has never seen himself on television before. Doesn't know which is his best side. But the bottom line is that nothing was eating those lobsters. I was lucky enough in the 1980s when the National Undersea Research Program was in full bore to go out to Cassius Ledge where there's still relative populations of large predatory fishes. And this is some footage I took from a submarine, but that's a lobster that's tethered on a patio block. And the yellow camera there is watching what's going on. We had a couple of cameras. Those are pollock mostly that you see up there, but there's cod, there's wolffish, big hunter. Sometimes the fish were so abundant that it actually got dark from the schools that were over our head back in the mid-1980s. But where I'm going with this is that the attack rate on lobsters was enormous. We were getting about 75% of all the lobsters consumed within 24 hours. And as a matter of fact, I lost 5 of those patio blocks. Yeah, the cod, they dragged them away. And you have to realize, it's not just cod. There are other, or I should say, were other really big predatory fish in the Gulf of Maine. This is footage taken up in Penobscot Bay of a wolffish. They have very bony mouths. They eat sea urchins. They eat lobsters. They eat a lot of scallops, too, I might add. They get to be about 5 feet long. It's a face only a mother could love. Not really very neat eaters, but the other thing that's interesting about this guy is really a demersal fish, but this fish really glides like a brick. Watch this. But the bottom line is this: if you look at all the large predatory fish in the Gulf of Maine, most of them are really rare today. And I think the important point is that the ecosystem really appears to have changed fundamentally in favor of the lobster. So we actually had a long history of big fish, and the top predators like cod, also wolffish, things like that, when they are abundant, they can control the prey. And the prey would include things like the sea urchins, lobsters, and crabs. I'm going to talk more about lobsters and crabs in a bit. But remember, low diversity system, we only have one herbivore in this system. It would, for all practical purposes, which is this one species of sea urchin. And it was probably rare at the time when the predators were abundant, and we probably had seaweed as a dominant cover on the coast of Maine. But with the overfishing that I've just kind of documented, you can make the case that the prey may have expanded significantly from that. And as the seaweed becomes rare, you end up with coralline barrens. But the abundance of sea urchins was just nothing short of remarkable back in the day. I know Paul remembers back in the day, but this did not go unnoticed. There was a sea urchin fishery that began in 1987. This was entirely an Asian market. At one point, it was second only to lobsters in value. There were 1,500 full-time sea urchin harvesters. But this is an example of a boom and a bust. And what are the bigger implications here? Well, in that we have very low diversity, and in that this is the dominant herbivore in the system, the fishing then directly impacts the process of herbivory. And so I used to go out and I would tether kelp strips. And just as an aside, I've shown pictures of the tethering of lobsters, and I've had people hiss me because I am tethering these animals, and that looks cruel. And I just think, well, if they're tethered, they're not going to be trapped in boiling water. But in any case, nobody has ever complained about me tethering kelp strips. But when you look at, I put those down to look at what is the rate at which they disappear. And so before the sea urchin fishery began, the kelp strips were disappearing at about 35% of the kelp strips per day. When the industry began, you saw that drop in half. The last time I got a measurable rate of consumption was 1994, and it's actually dropped since then. And so as the herbivory declined, we saw this remarkable increase in the kelp cover. And it's just a remarkable change. I'm at a mooring at Penobscot Point. It's not great footage, but this is 1993, and that's what the seafloor looked like, which was corallines and sea urchins and no algae. 2 years later, exactly the same elevation, it had become a kelp forest. You don't see that kind of change on land at all. And so the way we published this is showing that the sea urchin fishery came out of nowhere, and it's a boom and a bust. Sea urchin abundance that we were able to document at Penobscot was high, but declined in density and declined in biomass. And we saw this increase in the fleshy algae in the kelp forests, and we call that a phase shift. And so what we're looking at is after the overfishing dominated system. And so, this is actually reasonably well known now, but it's really an interesting question about is this really the result of fishing pressure on sea urchins, and why, in fact, have they not come back, given that there's so little pressure today? Well, what we know is that the flip, going from a barren state to a kelp forest, was rapid, but was it also synchronous? And so this line, right down Penobscot Bay, separates Zone 1 sea urchin fishery from Zone 2, and this is a testament to DMR's capacity to have creative names for zones. And what you end up seeing is that the region where people are most abundant and their urchin fishery began is one that peaked first and declined first. And then Zone 2 peaked second and declined second. Well, okay, I set up some sites in 4 regions, and looking at those regions, we looked at what was going on. In the New York area, looking at sea urchins, we see this rapid decline happening in the 1990s, and we look at that algal abundance of seaweed, and we see that increase. That happened in 1994. The mid-coast region, Penobscot area, we're seeing that change around 2001. Mount Desert is happening in 2003. Jonesport was always actually algal dominated, but my point here is that the shift was very widespread. It seemed to be correlated with the sea urchin fishery. But why has there been no recovery? And one could argue that, well, you're not going to have many babies if you take out all the mommies, and that makes sense. And so we went to the area in New York where we saw the first big decline, and we set up these little chambers that are looking at the rate at which the larvae were settling. And what we found, and we actually did this in an area that included a no-take reserve for sea urchins. But this is what's shocking. In 2001, we were seeing more than 15,000 urchins in a square meter. These are babies. They're about the size of a pencil dot, so they're tiny. Okay, that's a lot of babies, okay. But then when we looked at the older urchins and we lagged for time, we find that none of the urchins are living to be 1 year old. So there's plenty of babies, but they're not living to be 1 year old. And what's going on is that when this algal shift occurred, the habitat architecture changed fundamentally. There's Irish moss and other seaweed that became very abundant, and that's the perfect nursery habitat for baby crabs. And these crabs, they live in this sort of shag carpet, which is just perfect for them. Now, I was doing research on this, and when we come out of the water, sometimes, I'm working in these places that are iconic, and Penobscot, you name it, and there was a BBC film crew there, and they said, well, and this happens every summer. Many of you probably know this. That Maine is so nice in the summertime that the press thinks there's got to be something that we can cover. And so the BBC crew was there and said, oh yeah, this is a really interesting story because this used to be a barren, and now we have a shag carpet everywhere. And this guy just turned off the microphone and said, do you know what shag means in Britain? We redid that one, but anyway. So if you just tether these small crustaceans, these happen to be lobsters that we tethered on those patio blocks, the same ones that the wolffish carried away. But there's a lot of small, commercially unimportant species, or the sculpins or juvenile cunner, and the attack rate, if there is no cover, is really high. And so this seems to be a really important dynamic, because if you go back to the 1970s when we had these barrens, that happens to get baby sea urchin, the photograph I took in 1975. But it lasted that way for a long time until we had the spaceship, and this spaceship fundamentally changed the world. So it was hostile for settling crabs because they get eaten, but good for settling sea urchins. There's almost no food value in settling sea urchin. It then became the opposite, because these crabs eat the baby sea urchins, and it becomes hostile for the urchins, but it's great for the crabs. And so what we saw was the crabs start doing a lot better, and the question is this demographically important? Well, if you go to the National Marine Fisheries Service trawl data for our Jonah crab, from 1975 to the mid-1990s, there's a low density of those crabs. see a really different world. Now, in 2012, I was doing some ROV work, and this is off of Idaho, 100-foot water depth. There's a crab right there. And there's a crab, there's three crabs right there, just sitting right out. I mean, interesting. There's another crab. If you look off, I think to the left coming up, you'll see a lobster right there. I mean, this is like these guys hanging out on a parking lot. This is 9 Jonah crabs and 1 lobster in a 23-second transect off Idaho. I mean, this is a remarkable density. And we wanted to know if we could break this spaceship by bringing in adult sea urchins. You know, what ecologists like to do is play dumb, and it's always a mistake. But in any case, what we did is we went all over the state. We found places where there were still adult urchins. We brought them to a place called Cod Ledges off of, in the Casco area off of near Portland. We had 3,000 adult urchins per plot. We had 8 to 9 release sites. We repeated this twice. We translocated a total of 51,000 sea urchins. And then we watched what happens. And part of it was kind of a dub, and that is, we knew that there were micro-predatory crabs, and we knew that they were abundant. There were about 200 per meter square in this seaweed. But then they grow up, and they have an attitude, and that was something that I should have seen coming. But the experiment went like this. We put down about 3,000 urchins per plot, and that's what the average would look like for several months. And then the crab populations had been low, but then the crabs migrated in. We watched them feed on these sea urchins. They ate all 51,000 sea urchins, and then they left. And so we have a new apex predator in Maine. It's big crabs. And but also it changes our concept of the fishery. The Jonah crab fishery has been making a lot more money. And it's actually coming up right now in abundance again. And the question is, why didn't this happen before? We actually had seaweed when there was still cod around, but that's the whole point. This is a work that was published in 1879, and I was wondering, well, how do you get your crabs for that kind of study? The crabs are found in abundance in the stomach of the cod, taken in Casco Bay, and Jonah crabs are found in the stomach of cod, taken on cod ledges. That's exactly the ledges that we did our study on, but there used to be cod there in the 1800s. And so this absence of predators is actually really important, and it makes us reevaluate the kind of world that we see now, because it's an altered world. Arguably, this is a domesticated ecosystem, one where we've taken the predators out, and actually with lobster bait, we are actually contributing significantly to the nutrition of these guys, and that's our blooming fishery. And so when you look at the lobster story, you find that this is a really important point, and lobsters clearly rule in this system. And so, if you were just looking at all the coastal fisheries in 1927, you find that there's only one invertebrate, the lobster, that's not very high on the list. But if you look at it now, you see a very different story. As a matter of fact, bloodworms, which are used for bait, exceed the value of cod today. And coastal communities rely on lobster traps as far as the eye can see. I'm sure that's not news to anybody. But while the technology has improved, the stocks have not declined the way they have with other species, including sea urchins and cod. As a matter of fact, a front page photograph in the New York Times in 2001 shows, Vinehaven. It talks about the booming lobster stocks. And even the problem in 2012 having more lobsters than they know what to do with. In Penobscot Bay, we've seen this meteoric rise. And one might think that that's just good news, but is it a good idea to be so dependent on a single species? If you go back and look at the value of what's landed starting in 1950 and 1970, lobsters were dominant compared to 35 other species for which we've got data in Maine. Then we had the EEZ established, really excluding foreign fishing fleets. And you see a diversification of the species that are harvested, but this explosion of lobsters continues. And another way to show this whole story is as follows. If you look at the diversity of what is landed in terms of value with the black line, and then the percentage that's lobsters in the blue line, you see that with the EEZ, the diversity goes up. And part of this is the globalization of markets. A lot of things can be sold in Asia, we wouldn't have a domestic market here. That added to the diversity of what was being marketed. But then you see this remarkable decline in diversity. And what this ends up being is our lucrative monoculture. And, you know, this is one could suggest that this is a socioeconomic time bomb. And this is what ushers in the next part of what I want to talk about, which is the challenges of our changing climate. You know, it's a fact that if you just simply look at the planet, the areas that are warming the fastest are the poles. And among them, of course, is the Gulf of Maine. The data can be fancy, it could come from satellites, but actually I really like looking at DMR's Ruth Bay Harbor data going back to 1905, where you see a very obvious trend of warming. The other point I want to make real quickly is that notice that this little peak that happened in the 1950s, that's interesting, and I think it's going to be instructive. But here's where I'm going with this. Why the lobster boom? Lobster larvae and post-larvae, that's the Superman phase right there. After they hatch from mama for 30 to 60 days, they are swimming in the last stage near the surface of the water, and then they sound down. And they are actually looking to go to the seafloor, but they only survive in water that is warmer than about 12 degrees C. So if you actually, this is a study that was shown in terms of the post-larval abundances, and you can find that temperatures that are colder than 12 degrees C is too cold, and so there's a thermal threshold for this lobster settlement. There's also temperature that's too warm. And so if you look at the Gulf of Maine, the blue being the colder temperatures and those darker, those yellows or reds, I'm colorblind. But anyway, you go from warmer to colder as you go from western to eastern Maine. And there was a time when we thought it was really just too cool for lobsters in the mouth of the Bay of Fundy, for example. And that Maine has this sweet spot right in the middle. And then what we've learned in recent years is that southern New England really is too warm, and why it's too warm, well, it's climate change, but looking at lobster abundance in Long Island Sound, what we saw was a general increase in lobsters until 1998, which was the warmest year on the planet at that time, and a shell disease broke out. Lobsters get stressed, their immune system is compromised, and there was an 80% decline in the lobsters in southern New England, and that has not recovered. So the question is the Gulf of Maine becoming too warm? Is the sweet spot moving? And there's been a lot of press on this. Eventually, could Maine just simply be hostile to lobsters? Well, there's another component. So far, I'm talking about this spatially, but there's also this idea that if the warmer water's at the surface, and if it's a cool region or cool time, they're only going to settle down so deep. But if it gets warmer, they could be settling into deeper water. And we just recently, just this month, published a paper called The Brighter Side of Climate Change. You don't hear that very often. How local oceanography amplifies the lobster boom. And the bottom line is that, you know, the nursery habitats for lobsters can be expanded from this kind of warming. And so western Maine, going from a cool year to a warm year, the red color there is the expansion in western Maine. But if you look at the expansion in eastern Maine, it's much greater. So there's much more scope for increasing lobster populations, given the warming temperatures and the thermal threshold actually being a lot deeper now in eastern Maine than it was in the past. So there's a lot of notion that, in fact, the stocks in western Maine are declining. Well, that's incorrect. They're actually still increasing. The fact is eastern Maine is increasing even more. And for that reason, you're seeing the shift towards Stonington and places like that today. But if we go back and we look at this, you know, I led demographic studies from 1989 to 1999, 91 sites along the coast. And this year we revisited all those sites. And what I ended up seeing in 1989 was the highest abundances in York County, far to the west. By 1999, we found the highest abundances were in Penobscot. So I think we were demographics, we were capturing the wave moving from west to east. And overall, for the 1990s, we saw this pattern where roughly Penobscot Bay was the break between eastern Maine, which was still at that time too cool, to western Maine. And when we look at landings, you'll notice that in fact the inflection in the west is roughly in the mid-1980s and has been increasing ever since, which is actually kind of shocking. When I talk to some guys who are not young lobstermen, these are guys that have started fishing in the 1980s, they have never seen a significant decline in lobster stocks. That's really different. When I got started working with the lobstering community, these were guys who had been through really hard times. They had diversified fisheries, and it's really different today. But now look at eastern Maine, Washington and Hancock County, that increase is happening in the 2000s. And so when I did our study this summer, we found this kind of a pattern. But let me put this in context. This was only boulder fields because it was always in the case that boulder fields were where we found lobsters in highest abundance by far. When we looked at boulder habitats in the 1990s, we had a pattern like this. If I superimpose this year's data, it looks like this. That's really troubling. But here's a really interesting point. The red lines here are boulder fields, but that's going back to 1995. And what we're seeing now is, yes, a significant reduction in boulder habitats, but a significant increase in ledge and sediment. Now, so what we don't know yet, because ledge and sediment areas make a much bigger area, what we don't know yet whether there is a general decline. But where I'm tying these things together is, what shocked me more than anything was looking at the seafloor. The seafloor has a carpet of invasive red algae, Herbivory japonica, if you want to know the name, but it doesn't matter. There's tumbleweeds, balls of this algae in shelter habitats where I would always find lobsters. We found this ball of algae, and the algae is growing, it's breaking up, it's falling to the seafloor. I think in the small spaces it's rotting, and maybe oxygen is a problem. I think that this could actually be one reason why lobsters are less abundant in boulder fields, but also the absence of predators means that they can spread out, as I showed you in that other video. This is a dynamic that we're just pursuing now. But the Morgan Gulf of Maine has a lot of consequences, and I talked about that little blip up in the 1950s, because it's opening an invasion window to green crabs. Now, the green crabs are making a lot of press right now, but the bottom line is that the green crab first got to the Northeast in the 1800s, got to the Gulf of Maine in 1872. So this is not a brand new invasive. As a matter of fact, if you plot the migration of green crabs, what you find is the following. This is latitude and years. And what you end up seeing is that a very rapid increase of green crabs to Cape Cod, a 15-year gap, and then a moderate speed increase going up to about Penobscot Bay, 10-year gap, and then a slow creep in eastern Maine. And that whole reason for the rate change is because it's a temperature-limited crab. And this is not the first time this came onto the radar screen. The Department of Marine Resources became very concerned about the green crab because of what it was doing to soft-shell clams. And they published a paper in 1968, which was the following. It's a very interesting pattern where you've got green crabs and you've got soft-shell clams, and this is the first time they showed that when the green crab increased in abundance, the soft-shell clams declined. And this period of time of this green crab boom was that 1950 spike in temperature that I showed you earlier. So what we're talking about is a thermally triggered invasion. The invaders appear, but they only become serious predators when they can expand during the warmer periods of time. As a matter of fact, in the 1960s, looking at a more steady increase in temperatures, and green crabs are doing a lot better, and soft-shell clams are doing a lot worse. And so the sad truth is we may be actually losing soft-shell clams to green crabs. I mean, within the next decade, it's possible that it's going to be a very minor part of what we have to harvest and to eat. But what can we do? Well, how about eating green crabs? As a matter of fact, Madamet is looking into that. Those are our green crab spring rolls. Nancy, I'm not sure if you've reviewed them yet or not, but the whole idea of we're helping them with this project is trying to figure out when do green crabs molt. And as soon as they molt, if you can deep fry them, you get soft shell crabs, and apparently it's tasty. I haven't tried it yet. But why not? When we've done some crab trapping, we get tons of green crabs, so it looks like that's possible. But our warming speeds continue, and this has been known for a long time. Ken Drinkwater from Canada said that if we anticipated in the Gulf of Maine and Georgia Bank a 2 to 4 degree increase in sea temperatures, we may expect to see a very big change in codfish. And in fact, that's what you see. Where we had a decrease with 1 degree, by 2 degrees, we're seeing a change, and 4 degrees, which is a very realistic increase in the Gulf of Maine, at least the Drinkwater study, and others have suggested this, we're going to see the absence of cod. Now, at the same time, we have to realize that there are a number of species that are moving in. Red hake, for example, that was absent in the 1960s, has increased significantly in the Gulf of Maine. You probably all know about black sea bass. I remember hearing about them first from lobstermen. We're seeing them in their traps. If you look at their distribution, they're a mid-Atlantic species. But in fact, they are now showing up along the coast, and they're also being marketed, DMRs now, and there's more species coming. Squid is increasing in abundance. There's even some examples of blue crabs in western Maine, but I don't think they're reproducing here yet. So everything I talked about has to do with just the coastal system, and I just wanted to end with the last example being that it's more than just the coast, that the estuaries matter. If you look at the Gulf of Maine, that's where the watershed is. It's the entire state of Maine flows into the Gulf of Maine, including Nova Scotia. And there are lots of species that are really important in terms of the ecology both of the coast and inland. River herring, blueback herring, shad, and the role of estuaries and the dam problems and weirs is a big part of the story. One could say it's like a human health analogy in terms of what happens if you have blocked arteries. And you really should avoid that. And so the Penobscot watershed is a huge one. It goes all the way up into Baxter State Park, for example. And by 1630, we already had dams in the Penobscot area. And if you just simply look at this, and you look at this over time, starting in the 1790s, where we look at human population density in several different areas, Upper Penobscot River, Lower Penobscot River, and Penobscot Bay. On the left, you're seeing the dam proliferate. On the right, you're seeing populations increase. And, this is looking like an infestation. And it's a serious problem, of course. And the problem is one that, if you just look at the cumulative number of dams, 202 dams in 210 years, it's just striking. And then you see species that depend on these waterways, like Atlantic salmon showing decline, but also shad and alewife. And the alewife story, which is the black bars here, shows a significant decline when the Penobscot head tide dam was put in. And this is something that was written about, and I just love this quote from 1822. I, Joseph Butterfield, of a place called Indian Old Town in the county of Penobscot, do testify that ever since 1803, fish called salmon, shad, alewives were abundantly plenty in the Penobscot River, and that's that area, until about 1813, after which they have rapidly decreased every season. And I believe the vast numbers of destructive weirs were entirely destroying the run of the river fish. The Penobscot Indians cannot take sufficient quantities for their families to eat. And that low abundance has continued to this day. Weirds, as you probably know, catch these various migrant species. These are all photos, I think, from the archives here for Belfast Harbor, Bucksport, Rockport. And I turned the Penobscot River on its side for a purpose, to show you the fish weirs of 1873 in the Penobscot River. There's Verona Island. This is a map made there, and to highlight the weirs, that is the number of weirs that we were looking at in 1873, including right here in Searsport. And so the human health analogy is clear. There's the cumulative effects of blocked arteries, and what can we do about that? And that's where river restoration comes in. And as you all know, this has actually had a very big effect, and not only in the ocean, but also in terms of what it's doing to the terrestrial fauna as well. But seals and seabirds and cod all have forage fish in the way of alewife, and the numbers are really staggering. In 2011, it was hardly measurable, the number of adult alewives coming out of the Penobscot. Now it's over 3 million. And then there was just recently, they're showing the highest run of salmon of recent, and that might be related to some of this dam removal. And so what I wanted to end with, and one could argue you should start with this, but what did the Maine Fisheries landings tell us? Many of you probably know you can access these fisheries landings data from DMR. But I think it tells us a story of what I've just described, of extirpations, of booms and busts, of climate change, both good and bad, management, both good and bad, and improved aquaculture opportunities. First of all, extirpated groundfish. This is not news, but that's what cod landings in Maine look like today. It's a remarkable decline. Wolffish doing the same thing. Cusk, goosefish, or monkfish, Acadian redfish. These are all showing unmistakable demersal fish are flatline. But the decline of predators probably contributes to this remarkable increase in lobsters. It's the single most valuable species in North America is the American lobster. But it also contributes to booms and busts because the release of sea urchins and then the decline which resulted from overfishing, that in fact, since that is the herbivore that controls algal distributions, notice that there was this big decline to about the year 2000, and then if you look at the seaweed landings, and this includes mostly kelp, you'll see it really picked up in 2000s, and that's a direct result of the loss of that one herbivore species. Again, the booms and busts of this low diversity system. Also, with the sea urchin fishery and the Asian market, we expanded and we created other booms and busts, including sea cucumbers, which started in 1994 and pretty much collapsed in less than a decade. But then there's been a lot of management improvements. Scallops, for example, I think is one of our success stories. We saw this remarkable decline in scallops. They closed the fishery, and then they opened the fishery with the proviso that they would do rotational closures. And these rotational closures allow for the stocks to recover within certain embayments. They get harvested, and then they have a total allowable catch, and then they stop. Not only has scallop been increasing in abundance, but they've improved how they're marketed. So notice how the value, which is what I've highlighted here, has gone up. Very important point for fisheries going forward. And river restoration, which we talked about. The alewife has been on the increase. Statewide, it's not as impressive as it is for different estuaries, but we're seeing more river restoration projects. But also notice that the value has gone way up. And then climate change. You know, everybody, I think, in the room knows that our beloved northern shrimp we haven't had a quota for them for the last several years. By almost all accounts, this is simply the result of a warming Gulf of Maine. And then the invasive green crab, which I described earlier, this has led us to the lowest abundance of soft-shell clams that we have had since the 1950s when they started taking these records. And that is sad, and I'm afraid it's hard to be optimistic that that's going to turn around. But I haven't mentioned this, but green crabs are not just feeding on soft-shell clams, they're also feeding on blue mussels. And this most recent decline in blue mussels, with the exception of those that are suspended for aquaculture, for example, has been a result of the green crab explosion. Interestingly, the hard shell quahogs, which are immune to green crab predation, are doing well, and also there are several, like surf clams, that are doing better in Maine because they're mid-Atlantic species that are enjoying the warming Gulf of Maine. Oysters are a huge aquaculture. Oysters and salmon really rule, and oysters are doing very well, and in fact, in warming temperatures, the capacity to raise oysters is expanding. Also, there's been a lot of very good science and ways of raising oysters and raising spat and dealing with our changing climate, including deluges of rain. People like Little Mook just simply shut off their hatchery, goes closed circuit until that rain goes through, and then they open it up again. Brilliant stuff. Good way to adapt to climate change. I wish I had the most recent data on salmon. It's just proprietary apparently, but as far as I know, salmon generally in aquaculture is going up, and as you all know, this is a very hot topic in this region today. But the emerging fisheries, things like kelp, which are also being raised with aquaculture, is showing something that we describe as fishing down food webs, in that the higher carnivores are gone, now the herbivores are mostly gone, and we're actually now harvesting the seaweeds. And until very recently, we saw a steady increase in rockweed landings. I think you all know that's going to probably turn around quite a bit. Some conclusions. The Gulf of Maine, used to have a lot of big fish, and fishing has caused those to decline, but lobsters have increased, and it's the right temperature. There's no predators. The sweet spot is a sweet spot to be. But climate change is changing our cast of characters. Watersheds are important to our marine ecosystems, and river restoration is a positive change. This is a story about change, and aquaculture will be part of our future. The challenge is to get that right, and I'd like to just say there's an exciting water world in our backyard, right here on the shores of Penobscot, so let's just take good care of it. And with that, I thank you all.
May I ask one question? Because there's a really important species that was left out of your presentation, which is herring.
Yep.
I can't imagine much of a lobster fishery without a herring fishery. And so it's a two-part question. The first part is, do you think the overfishing of the apex predators helps the herring population grow? And the second part is, do you think the Gulf of Maine is going to get too warm for herring?
Yeah, and that's a very interesting point. And herring are really difficult to quantify because we do bottom trawls, but that's not where the herring are. But it looks like recruitment of herring has declined quite a bit. And the best guess right now is that the same thing that's causing a shift in right whales, which is Calanus inmarcticus, the copepod that's full of oil, is something that the right whales love, and it's what herring loves as well. And the climate has actually shifted to the point where that Calanus is actually farther offshore and up in the Gulf of St. Lawrence. And there's been a fundamental shift in herring distributions. And that's the best guess on that. The question might be whether something like alewife might actually take the place of the herring, but it's a very good point. It's a serious problem.
Does that mean that Canadians are going to have all of the herring and there won't be any left of the people of fishermen of Maine?
Well, right now we are importing a lobster bait from as far away as New Zealand, and it used to be until about 8 years ago, the biggest tonnage landed in the Gulf of Maine was herring. Now the tonnage of lobsters landed exceeds the tonnage of herring landed in Maine. Since it's roughly 10 to 1, 10 pounds of herring for 1 pound of lobster. We have to fill that up, and actually a lot of the bait is coming down from Canada, but we've also seen migrations of menhaden, which are locally called pokies, and the pokey harvest and the quota has gone up in this this area.